This is video clip 5 for micro part 1, and we're carrying on with consumer choice. In this clip, we're going to work towards utility maximization. So for a quick recap, so far we've looked at preferences, we've developed indifference curves and spoken about utility. The indifference curve slope we saw was the marginal rate of substitution, and that turned out to be the negative of the ratio of the marginal utilities of the two goods. We also looked at the consumer's budget constraint, the slope of which was the marginal rate of transformation, or the negative of the ratio of the prices of the two goods. Now we're going to combine those two tools, indifference curves and budget line, to identify the consumer's optimal bundle, in other words, to look at her constrained choice, the constraint being the income or the budget. So we're working towards utility maximization, which is a familiar idea from Econ 101. Individuals try to gain as much utility or satisfaction as possible from their purchase choices. We're going to capture it graphically, putting together our indifference curves, which show the utility we get from the goods we consume, and our budget line, which shows the combinations of goods we can actually afford to purchase. We continue with our example of Lisa, the consumer, to look at constrained consumer choice. Now, given information on Lisa's preferences and how much she can spend, in other words, her indifference curves and her budget line, we can determine her optimal bundle. And the optimal bundle is the bundle out of all the bundles that she can afford, given her budget, that gives her the most pleasure, or the most satisfaction. So let's put together Lisa's indifference curves and budget line in figure 4.9. You can see the budget line drawn in blue, showing all the combinations she can afford of her two goods, pizzas and burritos, and so far we have one indifference curve in the picture, indifference curve I3. Would Lisa be able to afford any bundle along indifference curve I3 for a start? No, she wouldn't, because they exceed her budget. She doesn't have enough income to afford any bundle to the right of her blue budget line. Let's add a second indifference curve, I1. Would she be able to consume any bundle along I1? Yes, she would. She could afford bundle C or bundle D or bundle A because they're all less than or equal to her total budget. But looking at those three, there are other affordable bundles that would still be preferable to bundle C, D or A. For instance, bundle E. Why would bundle E be preferable? Well, bundle E will be on a higher indifference curve than C, D or A, although it is also affordable for Lisa. Bundle E is called the consumer's optimum. If Lisa's consuming bundle E, she doesn't have any reason to change away from it because bundle E is on the highest indifference curve that she can possibly reach given her budget constraint. So another way of thinking about this is to say, given her budget constraint, what is the highest indifference curve that the consumer could reach? And you look for the consumption bundle on that indifference curve that just touches the budget line. Now the reason we're saying we want to reach the highest possible indifference curve is that the higher the indifference curve is, or the further it is from the origin, the greater the level of utility it represents. So in reaching bundle E, Lisa is getting the highest possible utility level she can afford because she's just touching that indifference curve I2, which is the highest indifference curve she can get to given her budget line. Now at point E, we can see that the indifference curve and the budget line are tangent. They're just touching at that bundle E. At that point, they have the same slope. So we can identify an important relationship that at the consumer's optimal bundle, or at her point of equilibrium, the marginal rate of substitution, which is the slope of the indifference curve, equals the marginal rate of transformation, which is the slope of the budget line. Let's focus a bit more on this important relationship that comes from the equality of those two slopes. What it's telling us is that in equilibrium, the rate at which the consumer will trade off one good for the other, in other words the MRS, will equal the rate at which the two are traded in the market, the price ratios, or the MRT. We can rearrange this into a form that you might recognize as being familiar from Economics 101. So rearranging that equation, we can see that in equilibrium or at her optimal bundle, the marginal utility of pizza over the price of pizza must equal the marginal utility of burritos over the price of utilities. And that simply comes from rearranging this equality here. What this is telling us is that in equilibrium, or to maximize her utility, the consumer should allocate her budget so that the last dollar she spends on each good brings as much utility across all the goods she consumes. And you might remember that as the last dollar rule or the last rand rule. The last rand you spend on each good should bring you just as much utility if you are maximizing your overall utility. Now, the type of example we've just looked at, where the consumer ends up with some of both goods, is referred to as an interior solution, and that is the most likely or typical case. But sometimes, given a consumer's preferences, we might end up with a corner solution, an exception to the rule where the consumer only consumes one good, and we don't have to look for the equality of the slopes. So let's look at the case of another student, Retabile, also eating burritos and pizzas, but with somewhat different preferences to Lisa's. You can see that her indifference curves are quite flat, reflecting a stronger preference for burritos relative to pizzas. She's only prepared to give up a small amount of burritos to get quite a lot of extra pizza. So her indifference curves are quite a lot flatter, and in fact, with the same budget constraint and the same price ratios, her indifference curves are flatter than the budget line. Her marginal rate of substitution is less than the marginal rate of transformation. So, we're not going to find a point of tangency. Retabile in fact does best to consume only burritos and no pizzas at bundle E. Why is that the case? Well, bundle E is on indifference curve I2, which is the highest indifference curve she can reach given her budget. So optimal bundle is E, which is only burritos, 25 burritos, and 0 pizzas. That is a corner solution. It looks as if it's in a corner. And it arises because of her preferences. You should be able to spot why bundle Y is not optimal. It gives her some of both goods, but it's definitely on a lower indifference curve, so it's associated with lower utility for Retabile. The best you can do in this case is her corner solution, bundle E, reaching the highest possible indifference curve. In the next video clip, we'll look at an application of our maximization theory.